we're just starting with some vocabulary. The first one is line of fit. It says that data does not always show an exact linear relationship. Okay. When we're talking about real world examples, how many times are you going to find a relationship that is a perfect linear relationship where the change in y is always the same and the change in x is always the same? Not a lot when we're talking about real world examples. Okay, so in cases like that, we can find something called the line of fit or the line of best fit with a scatter plot of data. So line of fit says data does not always show an exact linear relationship. When the data in a scatter plot shows an approximate linear relationship, you can model the data using a line of fit. And mathematicians calculate a line of fit by hand. So this is how you would do it by hand. If you were finding a line of fit, you would create a scatter plot. So you have a bunch of little points on your graph. You would sketch a line that most closely appears to follow the trend. So you want to go through about as many points as you can. There should be about the same amount of points above the line as below the line. Okay, but again, you are approximating that yourself. Then you're going to choose 2 points on the line and estimate the coordinates of each point. Right? Because how many points do you need to make the equation of a line? Just 2, right? So again, it's another approximation where you're choosing those 2 points that you feel best fit the line. And then you're going to write the equation of the line that passes through those 2 points. Okay? So you can see that there's a lot of room for error there. Does everyone see that? You are drawing the line. You are picking the 2 points that best fit that approximate line you just drew. Okay? There's a lot of room for error. So we're not going to spend a lot of time on line of fit because of that. We're going to focus more on line of best fit, which is a different thing. Okay? So it says, what is the downside to using this method? Well, there's a couple downsides. I'm just going to put a lot of room for error, right? You approximate the line. You approximate 2 points to use, right? And out of all the data points that are in that scatter plot, you're only picking 2 of those data points to get the equation of the line, right? Only using 2 of all points for line equation. Okay? So you can see with it being an approximation where you're deciding the best line, you're deciding the 2 points to use. Answers can vary a lot. Like the answers I had on my paper might be totally different than the answer you put down, right? Depending on which points you're choosing. So I'm going to say that answers for the line of fit may vary if you were asked to find a line of fit. Because of that reason, I'm not going to spend a lot of time in here on line of fit. I'm just like, let's just move ahead, and rather than doing line of fit, let's do line of best fit. That way we all have the same answers. Okay, so with that said, the line of best fit is a line that lies as close as possible to all of the data points. See how now rather than just using 2 of the data points, we're using all of the data points to get a line of best fit? It says the line of best fit is a more exact approximation than the line of fit. Many technology tools have a linear regression feature that you can use to find the line of best fit. So we're going to use our calculator to calculate what the best equation of the line is going to be. We're also going to be talking about something called a correlation coefficient. The correlation coefficient is denoted by R, called a correlation coefficient, which is 2 C letters, but for some reason they chose R to represent correlation coefficient. Okay? R is going to be a number from -1 to 1 that measures how well a line fits a set of data pairs. Okay? When R is near 1, the points lie close to a line with positive slope. When r is near -1, the points lie close to a line with a negative slope. When r is near 0, the points do not lie close to any line. So the correlation coefficient just tells how well the line is representing that data. Okay, so let's show some examples here, just so you can get an idea of what I'm talking about. So if you're at either end of the spectrum, if you're at -1 or 1, then you have a very strong correlation. That means that all the data points are going to lie really close to the line. Okay? At -1, it's a perfect relationship. All of your data points are going to lie exactly on the line. Okay? Strong correlation with a negative slope. So you're going to have all of your points right on the line. All the data points are right on the line. At 1, you have a very strong correlation, a perfect correlation. All the data points are lying on the line. It's just a positive slope line. Okay. And at 0, you just have a bunch of points. And you're like, okay, I don't care what line I try to draw through the point. There's no correlation in that data set at all. Okay? So r is 0. Okay, so we want r to be really close to 1 or really close to -1. Let's say I've got just some points on my graph like this. Like that. Okay, I've just been graphing some random points. You can kind of see what the trend is. Everyone kind of see it looks like the trend is a downward trend. You can guess what the line of fit might be. Maybe something that looks like this. Let's try to guess what r would be. In this case, because it's a negative slope, I know that r is going to be a negative value. How close do you think those points are to the line? Do you think it's going to be a pretty strong correlation, or do you think it's a pretty weak correlation? It's a pretty strong. I wouldn't say that it's perfect. They're not all on the line, right? But it's pretty strong. Maybe it's like -0.8, right? It's close to -1, but it's not quite at -1. Okay? No correlation would be something like what I drew up here, where you don't even know where to draw the line because it doesn't look like there's a trend. And then let's do a positive correlation. Let's do one that looks like, I don't know. I'm just doing this quickly. Something like this. We'll do one more point here. Kind of looks like it follows a positive trend. But what kind of correlation do you think this would be? It's obviously positive. Do you think it's weaker or stronger correlation than over here? Looks like it's a little bit weaker. I can tell it's an upward trend, but it doesn't look as strong. What might be an R value you would give it then? Like 0.6, 0.5, okay? So something that's not as big as 0.8, right? So maybe 0.5 or 0.6, okay, where we can see that there's a trend, but it's not a super strong trend. Does that make sense? Correlation coefficient? Okay. All right, so let's all, before I forget, turn our correlation coefficient on so that we know how close the data is to fitting the line. Okay, so to turn on R, you only have to do this once. Once you do it, it'll stay on forever unless you turn it off or reset your calculator. So this is how you do it. Here's my calculator. It says to go to second 0, so second 0. See how it says catalog? You can find everything in your catalog. Okay, second 0, and I want to turn my diagnostic on. Now, it would take forever to arrow down to the D's. See how this is in alphabetical order? So rather than arrowing down to the D's, you can use alpha D in order to get there quicker. So if you press alpha, and then look for the letter D on your calculator. Does anybody see a letter D? It's in the top right corner. See where it says matrix? Right next to it, it has a D. If you click that alpha matrix, you might have to do it twice. Alpha matrix. There we go. If it didn't work the first time, just do it again. See how it popped you down to the D's? Okay. I just want to get to where it says diagnostic on. See how it says diagnostic off, diagnostic on. Arrow to diagnostic on, and you're going to press enter. Enter. And then you might have to press enter again until it says done. Okay? Any questions on that? Getting the diagnostic on. Any questions? Okay. Once your diagnostic's on, that means that your correlation coefficient, your R, is going to be on forever, unless you reset your calculator. So now let's go back to the notes over here. And it says finding the line of best fit. So notice it says the word best. Best fit. That means we're using our calculator. It says the table shows femur length and height of several people. Does the data show a linear relationship? So we're going to just make a scatter plot and see if it looks like it has a linear trend.
Are we going to do that?
That's yesterday. Okay, so on your own, let's go ahead and just talk about what intervals we'll use, and then I'll have you just plot all these points on your own. Let's go up by, let's see, we go up to 45. Let's do like 10, 20, 30, 40, 50, like up by 10 on the x-axis. And actually, that's a good point, Dan. Let's maybe use a squiggly line. You know how we talked about we use a little squiggle to jump, make a jump from 0 to kind of a high interval. We are starting at what? What's your lowest y value? 141, right? So maybe let's do like one of those little like squiggles. And we're starting at 141. That's kind of an ugly squiggle. I'm going to do a nicer squiggle. Okay. We're starting at 141 and going up to what? What's our highest number? 195. So let's maybe start it at like 140 and go up to 200. So what might be a good interval to use? 20? Okay, sure. Let's do 140, 160, 180, 200. Let's do by 10. We'll space it out a little bit more, and I won't make my squiggle as big. Squiggle. Okay. We'll start here. This will be 140, 150, 160, 170, 180, 190, 200. Okay. I'll give you a second to go ahead and plot all of these points, because it might take me a second as well.
What do you,
45, 182. So you can start to see, like, as you're putting the points up there, are you seeing that linear trend happen? Yeah, it looks like it has a very strong positive correlation from our graph. Okay? So we're actually going to calculate, using our calculator, what the equation is of the line of best fit. Okay? So we can see, does it show a positive linear relationship? You say, yeah, and it's a strong positive correlation, right? Or R value. Remember, we're using R values for correlation. Okay, so we should see a really strong R value, right? An R value that's really close to +1. Okay, so we're just going to go through these steps together, how to use the graphing calculator to get the equation. Does everyone see how I've got this list typed out? Okay. So let's see if I can do this side by side here. It says part A, step 1, enter the data. So it says you're going to have to go to stat, edit. So everyone just go to stat. It's this button right here that says stat. Edit. See how edit's your first option? Press enter. And we have to clear out any data that's already in there. Yours might already be cleared out. If not, you can see over here I told you how to clear it out. It says arrow up to the L1, press clear, arrow over to L2, press clear, enter. So I'm going to arrow over to L1, I'm going to press clear and then enter. I'm going to arrow over to L2, I'm going to press the clear button, which is right here, clear, enter. Okay, so now they're cleared out. Somehow I jumped. Okay. Once you've got it cleared out, we're going to enter the data into the two lists. So in L1, I'm going to put all my X values, and in L2, I'm going to put all my Y values. So in L1, I'm going to put 40, enter. 45, enter. 32, enter, etc. 50, enter. 37, 41, 30, 34, 47, and 45. Okay. Once you've got the L1 figured out, arrow over to L2, and you're going to put all the heights in L2. 170, 183, 151, 195, 162, 174, 141, 151, 185, and 182. Okay. Make sure that your L1 and L2 are the same length. We're putting in ordered pairs, X comma Y. So if you have an X value with no Y value, your calculator is going to be like, what point do I plot? Your calculator is not going to know what to do. It's going to give you an error message. Okay, so you just want to make sure you have the same amount of data in your L1 and L2. Okay, any questions about that? Okay, so to calculate, once you get your L1 and L2 figured out, to calculate the linear regression, this is all you do. You're going to go to Stat, Calculate, number 4. So I'm going to go to my Stat button, see where it says Stat. I'm going to click Stat. Rather than going to Edit this time, I'm going to arrow over to Calculate. Okay, so Stat, arrow over to Calculate, and see how number 4 says linear regression. Okay. There's actually a lot. Next chapter, we're going to do a quadratic regression. Sometime in the year, we might do a cubic regression. I know for a fact that we're going to use, I think there's, exponential regressions. There's all kinds of regressions. Okay, but the one we're going to use right now is linear regression. Linear regression is number 4. Okay, so you'll press Enter. Okay, and for linear regression, it asks, it's like, what list do you want it to come from? Well, I want my X values to come from my L1. I want my Y values to come from L2. That looks good. I'm just arrowing down, and then I'm going to press Enter on Calculate. Okay, so press Enter. Okay, and there you go. There's my linear regression. You can see it's in the form mx plus b. It's just for whatever reason, rather than using an m, they used an a. Okay? It tells you exactly what your a value is. A is about 2.6, and b is 64.99, so about 65. Okay, so we get 2.6x plus 65 as our answer. Look at your r value. See how it's 0.99? There's our really strong positive correlation that we saw. Okay, so it's going to fit our data set really well. So up here where it says, if so, write an equation of a line of best fit, that's where you're going to put your equation. Y equals, we got 2.6x plus 65, approximately. It really makes that a point, pretty big point. Okay. And you can see I actually provided that screenshot for you guys as well. See how I provided the 2.6 and the 64.99 picture? Okay, just so you can remember what that looks like. All right, so now that we've got that regression function, it says graphing the regression equation. Okay. Before we graph it, we have to turn something called our stat plot on. Again, it's something where if you turn it on once, it will stay on unless you turn it off. Okay, so here's how you turn it on. See where it says before step 3, turn the stat plot on to see the data points. We're just reading that. I'm going to go to second y equals. So over here, see where it says second y equals? I'm going to click second y equals. See how my plot is turned on? Bless you. You're going to want to turn your plot on. Yours probably says off right now. How you do that is you're going to press enter. And yours is probably off. You want to arrow over to on and press enter. Okay? So again, that's second y equals. Second y equals, your plot is probably off. You want to press enter. And then you want to arrow over to where it says on and press enter. Okay? Any questions up to that point? All with me? So that's it. So once you turn it on, it will stay on unless you turn it off. Okay? So now let's graph. Now I want you to actually click graph. You're not going to see what I see. I did an example in my calculus class where I already have something in my y equals. I'm going to clear that out. And my window's all wonky. You might not see anything depending on your window. You've got all of these points that you want to graph, but look at the values of these points. Everyone see how high these y values go? You need to change your window, your viewing window, so that you see the points. Okay, so think about a window that would make sense for that list of points. It says y equals, enter the regression equation, window, choose an appropriate window, press graph. See how it tells you all that information there as a reminder? So let's go to our y equals and let's put in the regression equation we got. We got 2.6x plus what? 65, right? That's what we got. And let's go into our window. So I'm going to go into the window and we need to choose an appropriate window. Let's talk x values. What's our lowest x value here? 30. So we want to choose an x min that's less than 30. Well, maybe like 20. Sure. Okay. Less than 30. Now x max. We want to choose an x max that's bigger than our biggest number. What's our biggest number? 50, right? So we want to choose something that's a little bit bigger than 50, maybe like 55. Hey, you already had that in there. What do you know? Okay. What do we want to go up by each time? What's the x scale? Like, what do I want to go up by each time? Maybe like 5s, right? Go by 5 each time. This is under window if you're looking for where I am. Okay. Y min. What's our lowest y value? 141, right? So maybe choose what? Maybe like one what? 135, sure. That's a number less than 141. 135, sure. Let's do y max. We said the biggest number was what? 195, right? So 200, sure. And what do you want to go up by each time? Maybe 5s again. I don't know. That's fine. Okay. So once I have, right? Once I have entered my equation to y equals, and I've chosen an appropriate window, then I can press graph. See my data points? And see how we have the line, our regression equation that's running through the data points? That looks pretty good. Okay. the data points are only going to appear, these little dots are only going to appear if you have your stat plot on. If your stat plot is turned off, all you'll see is the line. Okay. Does anybody not see points? You with me still? Okay, so that's how you graph it. So I look at that and I go, yeah, that looks like a strong correlation, right? The last part, part C, is estimating another event or a future event. How can I use that information that I just got to create an estimation of a future event? Okay, let's see. It says up here, write an equation of a line of best fit and use it to estimate the height of a person whose femur is 35 centimeters long. So from this data, we concluded it has a linear relationship, right? Basically, we concluded that the longer your femur length is, the taller you are, right? The more the femur length goes up, the more the height goes up. And that makes sense, right? Like a short person isn't going to have a longer femur length than me, right? I'm tall because I have a long femur, right? So if I want to know the height of a person whose femur length is what? 35 centimeters long, I'm plugging in 35 for my femur length, x, and I'm going to get the height out, right? I just am plugging in 35 for x. You can do that with computation if you want. Like, I'll do it on the board. We know our equation is 2.6x plus something, right? 2.6x plus what was our equation? 65. You could just plug it in that way. 2.6 times 35 plus 65, right? And get the height of a person out. That's one way to do it. Or I want to show you how you can do it using your calculator. So let's say I didn't want to just plug it in and do 2.6 times 35 plus 65. Let's say I wanted to use the calculator. Here's the two ways it describes how to do this. Estimate a future event. It says you have two options. Option one is that you can do second calculate, enter the x value, and press enter. That is my go-to option. I think that that's the easiest method. I'm going to do second trace. Trace is up here. Does everyone see it? It's right here. Second trace. See how we've got a value? The next step says enter the x value. Okay, so I'm going to enter a value, press enter, and enter the x value. So what is my x value? 35. Okay, type that in, press enter. See how I get 156 out? Does everyone see that? 156? Okay, so that is the height of your person, 156 centimeters. That's how tall your person is. Okay, so that's option one. Option two is to use the trace feature. In that case, you are just pressing the button trace. And if you press the button trace once, if I press the over arrows, you're going to see it pops from one data point to the other. Does everyone see it hopping around? Okay. It's going to hop from one data point to another. Okay, well, if you have a data point where an x value is 35, then that's great. But it's not going to help you very much if you don't have a data point with an x value of 35. So if you're using the trace tool, you're going to want to arrow down to trace along the line to predict the output for an x value that's not in the data set. So if I press the down arrow once, down. Now if I press the left and right button, see how it's tracing along the line instead of hopping from data point to data point? We want when x is 35. So look at your x value. Right now I'm at 44. I'm going to arrow to the left until I get to an x value of 35. Oop. There's 34.9 and there's 35.24. So somewhere in there, right? It's not exactly 35. See how it's not as exact as option one? Okay? But it's popping between 155.95 and 156.6. So about 156. Right? You can see it's about 156 centimeters. It's just more exact to do option 1. Second, calculate a value at 35. Boom, exactly 156. See how it's exact?
I like that one.
I like that one better. I think it's faster than hitting trace, down arrow, shimmying from left to right. Okay, but shimmying from left to right. I do think that it's important though that you see that, because some teachers do use the trace tool. So if you go to another teacher next year, they might not use second calculate a value. Okay, so it's good to know both ways. Any questions about that? Okay, so let's go ahead and answer that second question up here where it says estimate the height of a person whose femur length is 35 centimeters long. I don't know why I wrote this. I'll do that in red. We're estimating the height, right? The height would be, let's see, when x equals 35, the height, whoa there, Sparky. The height is 156 centimeters. That's the y value. Questions, concerns, comments? All right, sweet. All right, let's go ahead and I'm going to scroll down to where it says student practice. Does everyone see that? It says the table shows the humerus length.
That's right here.
Where's the humerus? Okay, so I put the picture of the bone guy on the second page because I couldn't fit him in the first page. Okay, so your skeleton's on the second page. It's pointing to the femur, so you don't forget what that is. Okay, humerus, now it's pointing to the humerus, so you know where that is. Okay, we're finding the humerus length compared to height. Do you think it's going to be a linear trend? If my humerus is longer, do you think that means I'm taller? Yeah, probably. Like, people say that, like, if you measure your wingspan, that's how tall you are. Like, if you move my arms down, your wingspan should be almost the same amount as how tall you are. So it makes sense that if the humerus is longer, you should be taller. So we should get a linear regression. Okay, so I want you to do that. I want you to use the linear regression feature on your calculator to find an equation of the line of best fit. Okay, and then I want you to estimate the height of a female whose humerus is 40 centimeters. Okay, so use that second calculate, x is 40. Okay, so you're just kind of walking through the same process with me. So let's go ahead and start back at part A. It says enter the data, right? I want you to go to stat, edit, and I want you to enter the data. Go up to L1, clear enter, go up to L2, clear enter, and we're entering the data. So let's do that. Humerus lengths will go in L1. Okay. Then I'm going to enter all the heights into L2. Ooh, I almost put 16, 166. Okay. All right, what do I do after I have my data entered? What's step 2? Calculate the linear regression. Where do I go to calculate the linear regression? Go back to stat, right? Stat again. This time I don't go to edit though. Where do I go? Calculate, right? I arrow to the right to calculate. And what am I trying to calculate? The linear regression, the number 4. Enter, 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 enter until it calculates it for you, and bada bing, bada boom. There you go. Okay, so we get, what is that? 3.05 x plus 63.5. Okay, so I need you to write that down. 3.05 x plus 63.5, because you're going to have to help me remember it. Okay, because after I get my equation, where do I need to enter that equation? Into your y equals. So now go back to your y equals. What was it?
3.05
Plus 63.5. Okay. All right, so there we go. It's in my y equals. Now, before I press graph, what do I need to do? Thank you, I heard it. Say it louder. Window. Go to your window. What's the lowest x value that you guys see? 22. Let's pick 20. Okay, it's less than 22. What's the highest x value you see? 33. So let's just go from 20 to 40. Okay, sure. We'll go up by 5s each time. That sounds good. We'll just keep that the same. What about the lowest y value? 130. Let's do 120. I don't know. There's a number less than 130. What's the highest y value? 166. Let's go up to, I'm going to do 180 so that I can go up by 5s. I just feel like 120 to 180, I like those even numbers better. It's just a personal preference. 170 would have been fine too. Okay, so now that I've got that, and I'm going up by 5s there, now if I graph it, I see all my data points and see how that line runs through most of them. Okay, that looks good. There you go. And how am I going to use that line to estimate the height of a female who's humorous? The way I said that was humorous. Ha ha. That was pretty good. Whose humerus is 40 centimeters long. Where do I go?
Second trace.
Second trace, right, or second calculate a value. Press enter. What value am I putting in? 40. Press enter. We get 185.5 is the height. Okay, 185.5. You could have also done that mathematically. Once you get your equation, you could have just plugged in 40 for x in your equation. You can evaluate that way too. So just know that you can do it by hand or with a calculator. Any questions on how to use the calculator? Okay. So, yeah.
All the directions like on the notes.
Yeah. Yep. And I even try to put screenshots. Okay. So if you look at the homework that you guys have, you'll notice that the front page are your calculator problems. Okay. The first question, don't let it confuse you. Now, look at those points with me for question 1. I want you to understand that that is 0,11,386. Okay, so don't be confused by the commas. The second point is 1, 11,731. Does that make sense? Okay. So in your L1, you would put in 0, 1, 2, 3, 4, 5. In your L2, you would put 11,386, 11,731, etc. Okay, so remember your L1 is your x values, your L2 is your y values. Okay, so that's true for all of them. Even if you kind of fast forward down the worksheet, look at 5 and 6. See how I'm giving you points on a graph? Like in number 5, I'm giving you points on a graph. So this is the point, where am I? This is the point 1, 1. This is the point 2, 3. So you're using those data points to come up with your L1 and L2 list. Put all your x values in your L1 column, put all your y values in L2. So you have 1, 1, 2, 3. See how this is your x comma y? X comma y, x comma y. Okay? All right. Any questions for me? Please practice using your calculator. It will be on the chapter test, which is coming up next Friday. If you don't practice it for homework, you're not going to know how to do it on a test. You know what I mean? These are drilling hills, so the more you do, you're going to be like, okay, it's the same thing over and over again. Then that's going to feel like an easy question on the test. If you don't do it at all, good luck memorizing all the steps that we just went over. You know what I'm saying? You just have to do it over and over. Yeah. Cool. Alright.
Come on, you.